Hello physics students, we're talking about Newton's third law, law of action and reaction. In the first law, we basically said that forces cause accelerations. In the second law, we said how much acceleration. In the third law, we're talking about that net force, the total of all the forces, so all the forces that are happening. So every action has an equal and opposite reaction. For every force, there is an equal and opposite force. So if object A puts a force on object B, then object B exerts an equal force back on object A. So I'm saying that the first force, the action, is equal to the second force, the reaction. Equal in strength. Opposite, I'll put in a negative for opposite because that means direction. Okay, now because Newton's second law tells me that F and ma are the same thing, I can substitute in. So all I did was I replaced that F with an ma. Because F and ma are the same, I can trade them out. Now I want to point out that Newton's third law says that the forces are the same. It doesn't mean these masses are the same. It doesn't mean these accelerations are the same. For example, I could have a mass of 8 kilograms with an acceleration of 3 meters per second squared. And if that applied a force on a mass of, let's say, 4 kilograms, its acceleration would be 6 meters per second squared. Okay, now these both multiply out to 24 newtons. They both work out that same way. The forces are the same, but it doesn't mean these masses are the same, and it doesn't mean these accelerations are the same. This is why for a lot of people, Newton's third law doesn't seem immediately obvious, because they're thinking about accelerations. For example, if you have a rifle, and the bullet. You fire your rifle. This bullet has a large acceleration. Now you always place the rifle against your shoulder because of the recoil, because there will be a negative acceleration. That bullet will accelerate forward to a very high velocity, and that rifle will accelerate backwards, but not nearly as fast. But what we have to realize is that the forces are the same. It's the forces that are the same. Because this bullet had a very small mass. This rifle has a much larger mass. So if we look at the rifle versus bullet example, we have a large mass with a small acceleration equals a small mass and a large acceleration. But the forces are still equal. For every force, we have an equal and opposite force. So if we're looking at these pictures and we ask ourselves, what are the two forces that will occur in this picture? The action is hammer hits nail. Now, if we ask ourselves what the reaction is, a lot of people will make this mistake and say the nail goes into the wood, or the nail goes forward. That's not the reaction. The hammer applies a force on the nail applies an equal and opposite force back onto the hammer. If you've ever had to hammer a bunch of nails all at once, maybe 20 in a row, you'll feel your arm getting sore. That's because every time you hit, it hit back and all that force was absorbed into your arm. It will start to get sore. Now the same problem is happening here with the bullet and the rifle. That's why this thing's confusing. It doesn't seem right, not at first. You have to think about it. It's the forces that are equal, not the acceleration. It's true this little nail will accelerate a lot more than that hammer will. So this is going to have a high acceleration, and that's going to have a small acceleration. But the forces are the same, because this has a lot of mass and that has a little mass. Okay, when you multiply it out, this force equals that force. And if you want a better example of this, think about, you're getting frustrated with your physics homework, you have a lot of anger, rage problems, and you punch the wall. You apply a lot of force onto the wall. So you hit the wall. You can do damage to that wall, but that wall will do damage to you too. Because you apply a force onto the wall, it applies that same force equal and opposite back onto your hand. You hit the wall hits you. I think it's easier to imagine that force being reflected back like that. Okay, we can think about this little car. Tires are rotating, they push on the road. So the tire is pushed this way. The road, equal and opposite, same amount of force, pushes the opposite direction. So equal is how strong, opposite is direction. Now if the road was covered in ice, we'd have less friction, which means we wouldn't be able to push on as much, which means it wouldn't push back on us as much either. So in this picture, we could say the soccer ball hits the net. That's the action. The reaction, the net hits the soccer ball. Even before that, we could say the player kicks the soccer ball. The soccer ball applies that same force back onto the player. Equal and opposite. We can say that the runner pushes off on the ground. The ground pushes back on the runner. And if you've ever ran a lot and your feet were sore at the end, think about it. Every time your foot hit the ground hit your foot. I think the swimmer is a particularly good example to illustrate and really visualize it in your mind the equal and opposite force. Because the swimmer, the action is he's pushing back on the water. He's pushing water back. And if you look at a swimmer swimming across a large distance, you can see all that water being pushed behind him. Well, as he pushes back on the water pushes forward on him. And the harder he pushes the water back, the harder he's pushed forward. So those two forces are equal in strength and opposite in direction. Equal and opposite. So we have a rocket. All this gas is applying a force down. The reaction is that same force is being applied up. Now these force pairs don't cancel each other. You see the foot hits the ball, then the ball hits the foot. They're on two different objects. So the ball accelerates, so the force on the foot and the ball do not cancel. Because the foot and the ball both had different forces on them. Now, if there's two actions applied to the same object, so it's pushed this way and this way, if they're exactly across from each other and they're the same strength, those two actions will cancel out. But now those reactions will still be there. If these two kids kicked the soccer ball on exactly opposite sides at the same time with the same strength, the ball would not move because the two actions would cancel out, but both kids would still feel the ball hitting their feet back. So the reaction pairs don't cancel, but two actions could. Okay? So we'll be able to diagram all these forces in our next video, what we call free body diagrams. And that'll help us recognize all these different force pairs, because every time we have a situation, all of Newton's laws are applying. It's just a matter of seeing them. An object at rest stays at rest. An object in motion stays in motion. The force is equal to mass times acceleration. For every force, there's an equal and opposite force. There's all kinds of things happening here. And there's tons of events in the world that we can use to look at these different things. In order to make our visualization a little bit better, we're going to use free body diagrams in the next video.